It gives me great pleasure to welcome Dr. Satheesh Reddy, Secretary, Department of Defense R&D and Chairman, DRDO, to the VIF for today's Vimash talk on DRDO's achievements in defense indigenization. By conducting a successful anti-satellite test on 27th March, DRDO and its team of scientists and engineers have made every Indian proud. Our heartiest congratulations to the DRDO for their sterling achievement here. We could not have had a better person than Dr. Satheesh Reddy to talk about DRDO's achievements and the future direction of its work. And I'm sure in the course of his talk, he would also touch upon how he sees generally the ecosystem of innovation that is taking roots in this country. So may I request Dr. Reddy to make his talk.
Thank you very much for the introduction to DRDO. And thank you for inviting me here to come over and give this talk on what DRDO has done and what you need to do further in the course of time. I'll develop on the systems, primarily what have been developed, various systems by DRDO, which are actually developed / inducted and being developed also. To the extent possible, what can be put in the outside, the public domain, those things I'll cover, and naturally some of those things which we are taking up but which are not yet put in the public domain, we will not be able to cover them, and also see what course of action, what DRDO needs to do, how we can go ahead and things like that. When we say the systems DRDO has developed, firstly, right from the beginning, DRDO, academia and industry have been continuously working together, and the systems have been developed. Let me give the first example. When the first indigenous missile Prithvi, when it's made and flight tested, there have been a very good interaction with the academia, particularly with IISc and Jadavpur University for the guidance and control algorithms. And in fact, the algorithms have come from the academia, scientists were posted there, they worked together, and algorithms have come from there. Industry, of course, right in the beginning, the participation of industry was very minimal. Primarily were suppliers, and later little components manufacturers, BTS, and then they have grown today. Today, from BTP to BTS to people are doing research also and coming out with many products of their own research also. So whatever contributions are, primarily it is out of the contributions from DRDO. When I say it is DRDO, academia and industry. When we look at the missiles today, the systems which are inducted, the first one, primarily the large numbers which has gone into armed forces, both particularly the Air Force and Army, the Akash missile, which large orders have gone, and Bharat Dynamics Limited and BEL have produced in large numbers. That's one system which has got inducted into it. And then next, the series of missiles, the Prithvi, which was actually as a Prithvi 1 and then Prithvi 2, then it has got into Dhanush, that is the ship-launched missile. Then the Agni series of missiles, Agni 1, 2, 3, 4 and 5, all got into induction phase, productionized and induction phase they have gone into it. Then the Nag missile also has completed its developmental trials, and it is going through the user trials, and it's in advanced stage. Even I can say similarly, even Helena is also almost in the similar stage. Most of the development trials are almost getting completed. Probably a little more tests have to be done on the helicopter launched Nag missile. Helena means it's helicopter launched anti-tank missile. And so these are the other two missiles. And coming to the BrahMos, you know, it's the supersonic cruise missile. It's the Indo-Russian joint venture supersonic cruise missile. Again, it has been developed as a collaboration between Russia and India. That also has gone through all the trials, developed, and then it has gone into armed forces in all the three services, Army, Air Force, and Navy. And then the medium range surface to air missile, which has a capability up to 70 kilometers, which is again, it's a collaboration between India and Israel. This also has gone through the developmental trials, particularly for the Indian Navy, and it is in the process of induction is going on. Missiles are getting produced, and then already at least I think 50% of the missiles have been handed over to Indian Navy and going through. Coming to the systems which are under development, the first one is the Akash next version. Akash with a seeker for the Army is the system, which is again developmental trials are going on. Actually, a couple of trials have gone through, they are successful, and not much of a criticality is there in the system. The Helena, as I said, helicopter launched anti-tank guided missile, that also has gone through many trials, and it's very successful. Now there are no issues. Probably a couple of months later, some more trials will be completed and it goes into the user trials phase. Then there is another missile called quick reaction surface to air missile, which is actually the reaction time of it is very fast. It's actually a missile which actually tracks the target on the move, and then you stop and then fire the missile. This is also undergoing the developmental trials. Already a couple of trials have been completed. This year we should be able to do almost complete the developmental trials. The next one is, recently we had the trials called the Man-Portable Atgm, which has 2.5 kilometers range, which a man can carry it. This also have gone through some trials, and the trials were very successful, which have gone through, and this will go through the remaining trials and get into the user trials phase later. Astra, this is a air-to-air missile, which has been going through number of trials. Many successful trials it has gone through, and there are few trials left out now. Probably in couple of months, the trials also should get completed, and Astra should get inducted soon into Air Force. Then the next one are MRSAM Air Force, and then MRSAM Army, the medium range surface to air missiles. The MRSAM Air Force trials, also development trials, are more or less complete. You should get into the production phase sooner. You should get inducted also sooner. That's one. And MRSAM Indian Army, very similar, almost the same. If MRSAM Air Force is successful, MRSAM Army is automatically successful. That the work just began, and that should get through. There should not be any problem. Then BrahMos for the Air Force launched from Su-30. It's again we have already done a trial which is successful, and it will go through some more trials and should get inducted into the armed forces. The next one is NGRM, the anti-radiation missile launched from aircraft. This initial trials have been done. It has to go through trials, lot more trials, and should be going through probably this year, and should be able to complete the development trials by next year. This is another missile which is important for the Air Force. The next one is the Ballistic Missile Defense, BMD program, the phase 1. The development trials almost, I think, complete. The most of the trials have been completed. We need to discuss and see how these can be taken forward. Many times you have seen that, and these are the actually some of the basic core technologies from where the further development for the ASAT mission also has gone through, and this is one of the important element, as Dr. Arvind Gupta was saying. These are the this program, BMD program, is pursued by very few countries in the world. India is one among them, and where we also had successful hit of the missile with these technologies. Nirbhay cruise missile, again it has gone through a couple of development trials, and it needs to go through some more trials for that. Prahar is another a short range surface to surface missile. This is again being developed. It will be going through the trials. These are some of the missiles which are inducted and some of them which are being developed today. We can say that we are very self-reliant in these areas of missiles, the technologies-wise, whatever the technologies are required. Most of the technologies have been developed here in the indigenous way, and industries are producing in a big way in this. Let me a little bit say about this. When we say the Akash missile is being produced today by BDL, nearly about 85% of the Akash missile by value comes from the industry. So the BDL has taken the role of a lead integrator. That is the type of a system, ecosystem what has developed. And today BDL went to the extent of producing more than about 60 numbers a month. That sort of a numbers also started producing that as per the production rate what was required by the armed forces at the time. Next one, coming to the aircrafts. I think almost all who are here are well aware of this, the Tejas aircraft. And recently during our Aero show, we had the final operational clearance of this aircraft, and this is getting inducted into the services. It has gone through all the trials. Maybe very few things which need to be incorporated will be incorporated, and it started. HL started producing them and delivering them to the armed forces, and further orders also are in the process, and that gets through. And after that, parallelly the LCA Mark II development is also going on, which is heavier than this Mark I aircraft, and that development is also going on, and I am sure that this will not be taking that time what we are taking for Mark I. Having got the ecosystem, knowledge and whatnot, everything is developed in the country. Today, the scientists are very confident to go ahead with that. Similarly, parallelly, for Navy, both Mark I and Mark II developments and trials with the platforms which are built in Goa, the trials are happening and all that and going on. This is another development activity for the Navy, which is parallelly going on for the aircrafts. Coming to the unmanned systems, unmanned aerial systems, started with look at the Nishant is the first one what we have made as a unmanned system, which has got about 12,000 feet altitude and 4.5 hours sort of a system. So few numbers have been produced and used for a couple of applications. Then there is another Rustum 1 which has been developed, which is about 10 hours duration, and then about 15,000 feet is the altitude what it can fly. This is another one. Then the PTA, the pilotless target aircraft, which has been developed and which has been extensively used in all the SAMS testing, surface to air missiles testing, primarily for Akash. This is the one which has been extensively used. This is another one which has been developed and utilized in multiple applications. This one, I think again you are well aware, AEWC system, Airborne Early Warning and Control System, which has been made for the Air Force very specifically by DRDO and delivered the systems to the Air Force, which is again being used by the Air Force in a big way. The under development system, primarily the Rustum 2, which is supposed to be flying at 30,000 feet and more than 24 hours endurance, is the one which is right now trying to achieve the targets, slowly progressing, and try to see that you reach the actual target specifications of this. This is another aircraft, another unmanned system which is being developed. Continuously the system is undergoing trials and upgradations on that system. Coming to combat vehicles and related systems, as you are all again aware, Arjun Mark I is one system which has been developed and inducted in numbers by the Army. Then the development of Mark II started, which has gone through the development phase. Recently we had the trials, and the trials have been successful of Mark II, gone through that, and Mark II is also probably will get inducted soon into the armed forces, is Mark II-wise, or Mark 1A we call it actually. That is another one. Number of bridges have been developed which are used, modular bridges or otherwise by a laboratory called R&D Engineers in Pune, 20 meters, and then this one is going to 40 meters sort of a thing and all that. Then there have been vehicles which have been developed for a couple of applications like reconnaissance applications. What you have here, this vehicle what you are seeing, which has got all the features for the reconnaissance what is required. And also there is Arjun armored recovery vehicle and things like that, repair and recovery vehicle, ARRV, those sort of many platforms which have been developed. These are all that platforms what you are seeing here. These two of course the bridges, these are the vehicles. This one is another class of a vehicle what has been developed is a wheeled armor platform. With industry collaboration, this has been developed for a specific application at the time, but now it is finding its utility in the armed forces. There are discussions going on, and the modality of utilization of this WAP system, which probably I think sooner we'll be able to finalize this and get through that. Coming to artillery and armament, one of the success story is the Pinaka Rocket, which has gone in a large number into armed forces, which number of regiments it has gone through, and it has been found, and systems are being produced by industries, ordnance factory and all that. And then the INSAS rifle, which has also been produced in the country, it's gone in large numbers, and some of the ammunition which is required for Arjun has been developed. But then of course not much of progress has happened in this area of particularly the small arms, which actually recently we have taken up very seriously, and based on the requirements what have been RFP floated by the armed forces, started developing some of them. The close quarter carbines, 30 mm, 45 mm related and all that, and some of them have gone through the trials also. Some DAC has given some approvals for some of them also, and we should be able to come back in this area sooner. That's what I feel. Then the Pinaka has been converted into guided Pinaka, putting a control, guidance and navigation system on board and trying to extend the range, improve accuracy. It has gone through the trials, successful trials, and it is in the process of induction. Then this is another gun which has been ATACS, which has been developed with industry, which has a range close to about 50 kilometers. 2 guns have been fielded and some trials have gone through, and some more guns are getting produced. Army has shown very serious interest into this gun, and they are going through the trials now. I am very confident that it will be able to go through these trials and get inducted into the armed forces as projected by them. Then you have a multimode grenade, both for defense and offense applications, developed by a laboratory here in Chandigarh, and that laboratory has fielded it and gone through the trials. Industry has come up, industry has taken this technology, industry has produced it, and large numbers it will be inducted into the armed forces very soon. Then couple of ammunitions like FSA PDS have been developed and has shown successfully and is going through the trials, and number of warheads have been developed, whereas thermobaric or PCB type of warheads have also been developed, and they're in various phases of development. Some have been inducted, some have been used, some of them are getting developed, like concrete penetration warheads for various depths or the width of the concrete wall. There are varieties right from 1 meter to 5 meter and all that are being developed in this area. Coming to the electronic systems, radars, this is another area what I can say that country has really progressed very well, and we are confident about the technologies. Many radars have been developed in the country. Even couple of radars for applications of like BMD applications what have been imported earlier have also been now developed in the country. Many radars have gone into with the armed forces, whether it is 3D tactical control radar, or weapon locating radar, or the Bharini radar, or battlefield surveillance radar, and particularly the Rajendra radar for Akash, the Revati radar for naval applications, and the Rohini surveillance radar and Aslesha radar. Many of those things have been indigenously developed, which have got inducted into the armed forces. And today, in advanced stage of development, like the quick reaction surface to air missile radar, the air defense flight control radar, or the tactical control radar, or triple LR radars, which are in very advanced stage, which have gone through the trials and all that. And similarly, when you look at it, the radars for like LCA, AESA radar, it has been developed and it is also going through trials in the LCA aircraft. And the SAR radar is also going through the trials in a way, synthetic aperture radar. The medium power radar, Arudra, is also another radar which has gone through the trials. I am sure it will be inducted into the armed forces very soon. Even the HPR also, the development is going on. High power radar is another radar which have been developed. And some of the radars like LRTR radar, long range tracking radar for the BMD applications also have been developed. As I said, this is one of our strong areas where now you are able to develop varieties of radars and trying to catch up with the advanced technologies. And industry has come up well in this area. Industry, in fact, this area, RF area, has been not good till about 10 years back. Now, a couple of industries have come who are able to come up with many of the subsystems and systems. They are able to produce whether TR modules and related technologies or the signal processing units and all that. They are able to come up and industry is able to do well. And so with the cooperation of the industry and some of the R&D centers and then Bell, we are able to produce many of these radars in the country today. Then another area is the EW area, electronic warfare area. Again, this is one area where we have produced many systems for all the applications, whether it is Army, where you look at it, Samyukta, or SATCOM related, or Himashakti systems, what have been made, gone through the trials, and some of them are inducted, some of them are getting inducted now. Or similarly, when you look at it, the Sangraha and Varuna and Dolphin, these are the EW systems what have been made for the naval applications, and Divyadrishti for Air Force applications. They have all gone into the armed forces. And some of those systems are also under development, rather advanced stage of development, Girishakti, and then S-band terminals for GSAT-6, which have been developed by a laboratory in DRDO, which have actually made in number of form factors all these systems. And even the software defined radio also. This is one which has been developed by this laboratory, SDR, which has gone into the naval applications. Navy has taken these SDRs and in multiple form factors, it has been made and is being used by the Navy. And sooner we'll be able to do for the other applications also. As the new waveforms are coming and you need to adapt to the new waveforms, there are a mixture of imported systems and indigenous systems need to get into all the waveforms, and then you have to work together and through meeting all the requirements is a issue here. So that's how it takes time in these applications, where you are completely on your own and you are able to define your waveforms and you are able to go ahead, you are able to develop the systems. But when you need to match with others, the issue comes, and that's how some of the systems, even though they have been developed, could not be inducted, like in armed forces. Some of the radios and all that, we could still struggle with that type of a issue. Otherwise, this is another area where systems of EW systems, number of systems have been developed, and as I said, SDR also has gone into the naval applications. This is another area for the Navy, sonars. Many sonars have been developed for the ship applications, submarine applications. As you are able to see, the Hamsa, Vushas, and Abhay sonars, they have been completely indigenously developed in the country, inducted into the Navy, it's gone into the naval applications, and some of them are being getting developed like ALTAS, towed array sonars, and some of the diver detection systems and all that are being rather going through the trials, being developed in the sense most of them I am talking where your the developmental trials are going on. This is one area. Then coming to the torpedoes, these two torpedoes have been developed and also have been delivered into the armed forces, getting developed and delivered also into the armed forces today, whether advanced light torpedo, TAL, or the Varunastra. These two have been accepted and getting into that, and Marich anti-torpedo system also is another one which has been accepted by the Navy, and the systems are getting into it. Then working on the new generation systems, advanced lightweight torpedo, and also electric heavyweight torpedo. These are another systems, and also country is working where you are very confident of developing the systems is air independent propulsion by another laboratory. These are the areas which will get into, I am sure, should get into the armed forces couple of years later. Definitely we should be able to meet the requirements also. This is one area again country has done well, particularly in the sonars and related aspects, and then later in the torpedoes also. Coming to the devices, some of the devices could be developed in the country, what you need for various applications, like the transmitters, what are required for various applications of seekers and related applications. Country has developed. As I said, the TR modules which are required again, whether gallium arsenide based technology or MEMS based related technologies, then some of them could be developed. Country could develop its own MEMS based pressure sensors and some of the accelerometers what are required by the couple of societies what have been established, and also look at the system on chips type of a technology. The country again could make its own system on chip, and that also has gone into applications. Is some of those devices, I didn't mention detailed way, but then some of these are what have been developed by the country and gone into gone into various systems actually, which our system has been developed and delivered to the armed forces. Coming to the secured communication and related activities, number of systems have been developed. I don't want to get into too many details into it. For varieties of communication equipment related, various encryption algorithms and devices have been developed, which have been graded and being used by the armed forces and being developed by the DRDO even today. And it's a continuous process which you need to develop as the new schemes and new mechanisms and new technologies are evolving. But then there is one area where a lot of work has gone into these areas of these systems. Coming to NBC, the detectors, the devices, and suits. These are some of the areas where a lot of work has gone in. A lot of systems have gone through the trials. A lot of systems have been lot of things like you see the type of a vehicle what has been developed here, NBC recce vehicle, and then some of the devices which have been detectors which have been developed for detecting various chemical agents and related aspects of it, and the decontamination equipment which has been developed, or the suit what has been developed, NBC suit. These are various systems which have been developed, which have got into actually a large number which have gone into the armed forces developed from this cluster. Similarly, when you look at it, varieties of other equipment, integrated life support systems, are the G-suit and helmet, mask, then combat free fall oxygen system and HAPA bag, are varieties of applications which are required for various applications. Like if you look at it, even working on the ration of the armed forces at various places, high altitude and other places and all that. And these are many systems which have gone into armed forces at various location-based and application-based sort of a requirement which had been developed. Then coming to some of the technologies, one of the most important requirement is the materials is one important area for any country. I always say that there are actually two areas which a country has to be very strong if it has really become an advanced nation. The first one is materials. You need to be very strong in the materials, whether varieties of alloys what are required for various applications, whether right from a bulletproof jacket to talk about very high temperature applications or very high strength materials which can take very high loads and things like that. This is our composite materials related whatever areas. If a country has to develop a hypersonic missile, then you need the first and fundamental element what you need to work is on the materials. Need to have the materials which can take that type of a temperature load, and also the physical loads what come onto that when you are actually traveling through atmosphere with about 10 Mach or something like that speeds, the type of loads what they come onto the hypersonic is this area. So in this area, a lot of work has gone. There are a couple of laboratories. One leading laboratory being DMRL in Hyderabad, and then there are two other laboratories, one in Kanpur, another in naval applications related in Bombay, who have developed varieties of materials, paints, gels, and all those things which have gone into various applications what you are doing today. Today, when we say that we are able to fly long-range missiles like Agni or other missiles today, you have the composite rocket motor casings, you have the flex nozzles and related materials. Many of those materials, the type of temperature what it encounters in the re-entry, those materials have been developed indigenously in the country. Industries have come up and industry is able to produce them and give it. And those materials have been developed, and it is a continuous process which you need to develop. Still, you need to develop a lot in the country, right from rare earths onwards. Country needs many materials which need to be developed in the country, which actually, when Dr. Arvind Gupta was there in as a deputy NSA, we were working on this, how to progress this work and see that country becomes self-sufficient in the materials. I was talking about two areas. The second area is when you say the materials, the next important area is manufacturing. There is another important area, what type of innovative manufacturing technologies you are able to develop yourself, and then you are able to produce with ease and then quality. The manufacturing mechanisms for various applications. In the sense, when you talk about manufacturing, right from textile onwards, you talk about manufacturing technologies or electronics, flexible electronics, foldable displays. From there onwards, today you talk about additive manufacturing or this type of technologies. So that is how actually a country can produce with at a lesser cost a particular item what you require when you have an innovative manufacturing process and mechanisms in the place, and then only will be able to produce, then only will be able to compete with anybody else. So these two become very important areas, materials and manufacturing. This any country needs to concentrate a big way. Some of the technologies, when you look at it, the missile technologies, almost all when you are looking at it, most of the technologies are completely have been developed indigenously here when you look at it and being produced. A number of industries are there which are able to produce here. You are able to see here the composite rocket motors and then some of the structures what are required for this applications, the composite structures and the flex nozzles and related things which have been developed, whether it is control systems and pneumatic actuators or hydraulic actuators or electromechanical actuators and navigation systems, or the radio frequency related RPFs or seekers and whatnot have been developed completely indigenously in the country which has gone into it, including the propulsion technologies. And some of the critical other technologies when you look at it, again I was talking about the composite materials technology here, or the high temperature which is used in the nose cones of re-entry vehicles and related things, or the complete RF technologies what are required for it, whether you talk about KU band, you talk about X band or W band or Ka band, and many of those things have been developed. The IR seeker technology is another one which has gone into the anti-tank guided missiles, ATGMs, or the domes what are required for this, or for the ballistic missile defense technology. These all have been developed inside within the country, various industries are able to develop these things. Yes, there is no doubt about it. Still, the country needs to develop some of the devices. Detectors is one thing which country needs to develop. When you say devices, you need to have a foundry in the country. You need to develop the complete electronic chips, whether you talk about 25 nanometers or you talk about even we talk about 7 nanometers or whatever it is. Also, you need to develop those things and some of the detectors and related also. These are some of the navigation related sensors and systems which again have been developed in the country. Completely, you made the systems for all applications, whether airborne applications or naval applications or the missile applications. These systems have been developed in the country completely. Now, from here, when we say about the technologies, some of these technologies, let us just talk about the mission Shakti, where these some of these technologies have gone. This is the missile which has been used for the intercepting a satellite, and this is the satellite which was there in the low Earth orbit, and the neutralization is by a direct hit within a very short time of few minutes from the takeoff of the interceptor missile. You are supposed to intercept the satellite. This is the, as I was saying, this is the vehicle. This is the complete vehicle, a two-stage propulsion and a kill vehicle. You can see this is the second stage and this is the payload. And this is the payload without the heat shield. After some time, after kill vehicle is separated out, then the heat shield is ejected, and then you have the IR seeker which is able to see the satellite. It is about 19-ton weight and 13 meters is the length of the vehicle. As I said, two-stage solid propellant and then the kill vehicle, and you have the divert and attitude control systems and the reaction control systems, and terminal guidance is hit to kill with a strap down IIR seeker. And when you look at the satellite, it's below 300 kilometers altitude and has a velocity of about 7.8 kilometers per second. And the challenges in this are dissection in hit to kill mechanism, meaning you are going and hitting it, your accuracies have to be very good, and closing velocity is more than 10 kilometers per second. Close to about 11 kilometers per second is the type of velocities what you have here, wherein you have to engage the target with the type of velocities. This is the overall scheme of the systems. The sensors detect and pass it on to the command control center, and then this fellow sees the feasibility of an engagement of the satellite, and then it passes on to the launch center. Launch center computes the ground guidance system, continuously computes the actual time of launch required for the interception, and then automatically the missile is launched. The complete operations are right from powering up the missile to the takeoff of the missile is completely automated based on the data what it is coming here and things like that. And then of course, till the second stage is separated, you are pumping the information of the upgrading the target information to the missile. You have a very secured data link which goes to that missile through this. And this is the typical scenario, engagement scenario. When you look at it here, the satellite is coming from here like this, and you are here at on the east coast, and then you are launching towards the target, and then this is the engagement scenario what you are seeing here. And then this is the vehicle. When you look at it, the first stage gets separated here, and then the second stage gets separated here, and then you have the kill vehicle, and then the kill vehicle with the heat shield open and IR seeker looking at the satellite, and then the terminal guidance algorithm takes over and takes it to the target. The critical technologies which have gone into it are the RLG based accurate navigation system and related mechanisms of onboard computer and interface and all that. And then the divert and attitude control system, the very fast response solenoid valves what have been used in conjunction with this DACS system, and then the strap down IR seeker what you are seeing here, and then the dome opening mechanisms and related mechanisms. The industry has participated again in this mission in a big way. More than about 50 industries have participated in this mission. More than about 2,000 components have been realized through industry, and many of the critical systems have been produced through industry which have come here, which you are seeing right from solenoid valves to many systems which are right from composite rocket motor or the nozzles and actuation systems and all that have come from industry. The quality system has been brought in there, and a lot of internal quality, external quality, and the quality assurance agencies have participated in the thing. And then the mission planning, when you look at it, the interceptor, even though it has the capability to engage the targets even up to 1,000 kilometers, looking into the aspects of the debris, it has been chosen below 300 kilometers, and you are well away to the ISS. And head-on engagement has been planned so that the debris will not have much vertical velocity to go up, and also to see that the debris decay in a matter of few weeks. So that's how the whole mission has been planned, and then the interception has been planned at 283 kilometers, and what you have been done at 283 kilometers. I think that can be seen later in the other the video here.
Space has become an important element in a country's economy and military superiority. Capability to defend against the space-based threats is a necessity. Mission Shakti is a major breakthrough in demonstrating the country's advancing technological capability of engaging satellites of low Earth orbit. The seeds for the ASAT test were sown back in 2014 when Prime Minister asked DRDO to work on challenging technologies. The National Security Advisor then held a series of discussions with DRDO on the subject, and the final go-ahead for the test was given by the Prime Minister in 2016. The objective was to neutralize a satellite in orbit while ensuring the safety of other space assets. It was imperative that the test be done at the lower orbits, which posed a serious challenge of highest speeds. A multi-stage interceptor missile with a hit-to-kill capable kill vehicle was configured with advanced technologies to handle closing speeds of more than 10 kilometers per second. A long-range strapped-down IIR seeker with hit-to-kill guidance and control, ring laser gyro-based navigation system, and precision divert and attitude control system with quick reaction valves made the technological feat possible. The highest level of classification warranted the execution of the task in the shortest possible time. While only a small group knew what it was really about, the work was done by many teams across the labs. Nearly 150 scientists worked round the clock. The system was realized, integrated, and brought to the flight test stage in a record time of 2 years. Many industries were engaged for the realization of components and systems in a concurrent mode, demonstrating maturity of Indian industry contributing to complex missions. Extensive hardware in the loop simulation tests were conducted to fine-tune and validate the design under all possible dynamic conditions to achieve the required accuracies. Meanwhile, a satellite was launched in an orbit under 300 kilometers to serve as a target for the mission in January 2019. The systems of BMD like radars, data links, communication network, and ground systems were deployed over a wide geographical area for the mission. The weapon system detected, tracked, and classified the target as a satellite to be engaged. The ground guidance system computed the exact launch time, and the missile was launched at 11:09 hours on 27 March 2019. The booster stages had taken the missile to the required heights and velocities before the kill vehicle was released. The heat shield was ejected subsequently, and the IIR seeker locked onto the target at the expected range. The terminal guidance executed the small and precise corrections to the path of the kill vehicle, and the target was hit at the intended aim point within 10 centimeter accuracy. The intercept occurred at 283 kilometer height in a hit-to-kill mode. The radars and electro-optical systems captured the interception, and the onboard IIR seeker's last image also confirmed the same. The Prime Minister was informed about the success of the mission.
आप सबका अभिनंदन।
Underlining the importance of the trial, the Prime Minister addressed the nation.
भारत ने आज अपना नाम अंतरिक्ष महाशक्ति स्पेस पावर के रूप में दर्ज करा दिया है। अब भारत चौथा देश है जिसने आज यह सिद्धि प्राप्त की है।
Jai Hind.
So look at the achievements. All the critical technologies which are required are indigenously developed. All the systems functioned as per the design requirements. Hit to kill against live satellites with accuracy of less than 10 centimeters has been achieved. When you look at it, the satellite, you must have seen the IR image in the end. There are two solar panels, and the center portion is that, and which is about 1.5 to 1.4 meters. And if you take the geometric center of it, most of our simulations have shown about less than 10 centimeters is the accuracy what it has come. And when you look here at the last frame and look at the extrapolations and data, also confirms that you could hit it with better than 10 centimeters accuracy what it has gone. It gone and hit it and destroyed it. And mission was very carefully designed to see that debris are not an issue, and active participation from the industry in all this. And when we, this is part of the technologies when I have mentioned, and so this being the latest mission and what we had a great success, so I have gone into little details of it. Coming back to the whole theme of the topic, initiatives with industry and academia. When you look at it, as I said, we have been working with industry and academia in a big way. Particularly when you look at it, the academia, you have direct number of research centers have been established at various academic institutes. Then you have the research boards in the aero, naval, armament, and life sciences, which actually engage the academia for the research. Then you have IPR, this is extramural research. Again, you engage lots of academic institutes, number of projects you give and engage the academic institutes. And also the laboratories level, you have the CARS projects. This is for the contact acquisition of research services for various professors and students for varieties of applications. Then of course, the other things are for the industry related. You have the Technology Development Fund and other schemes which are there for the industry engagement. These are the academic institutes, research centers. When we say that, we have the propulsion technology related center, which is there at IIT Mumbai. And of course, IIT Madras is also, IIT Chennai is together trying to do lots of propulsion technologies related technologies here. Then you have another center at Delhi IIT, a big center for varieties of applications, right from electromagnetic applications, ballistic applications, and BPJ related applications and all that. Then we have another center at Kolkata, Jadavpur University, working on directed energy related aspects and robotics and related aspects of that. And then we have at Bharatiya University, Coimbatore, for the life sciences related applications. And we have a center in IIT Madras, again working on some of the electromagnetics and microelectronics related applications, naval systems applications. This is one center which is there in IIT Chennai, IIT Park. And then we have for the high energy materials related things, where actually most of our propulsion systems get benefited out of it, is from Akraham, Hyderabad, the Hyderabad Central University, Hyderabad University. These are some of those things which recently we started another collaboration with Mizoram University also. Coming to the funding of industry, there have been various mechanisms how we have been working with industry. When we want a specific technology-based product to developed by the industry, we have been funding them. We have been ensuring that the related equipment is required by them and things like that. That is one of the areas. Then we also have a model called GOCO model, government owned and company operated model, meaning we establish the infrastructure and the industry operates it and produces those systems and supplies to DRDO and other applications. Like example, I'll give you the servo valves are being produced in the same model. The complete infrastructure is made by us and the industry works. Then this is a technology development for any specific problem. When industry comes out with a solution saying that I will be able to do, and he needs funding for the development of that particular technology, you are funding the industry for that application. Lots of industries have registered, and we have put in our website more than about 128 or 138 problems in the website, and which industries are coming forward to work on those technologies and which will be funding them and coming up. When we say indigenization, this is one important thing what we need to look into it. This is the type of indigenous systems what we have produced, and the total value is about close to 2,70,000 crores of equipment what has been inducted, rather under induction. You can see here what is the Army, Air Force, Navy, what it is, inducted, under induction, what is the type of percentages of this total induction, already inducted, being under induction. These are the figures what you are seeing for the total figure of whatever I have given here, close to 2,70,000 crores. And this is okay, I think we'll go into next one. When you look at the indigenization and the percentage of indigenization, look at the imports what you have. Which sector has the maximum imports and what we need to do here. The large platforms are the one which actually make the number of the import go high. Either you buy submarines or buy ships or aircrafts, and that is one area where actually the percentage of import is making high. So this is one area I think the country needs to look into it very seriously, wherein we are able to build the large platforms. Over and above the many of the technologies what are required for this, whether it is devices, sensors, materials and whatnot and all that is one of the areas. That of course I have already listed out where you need to work and where you should be able to do and you should be able to develop in the countries and look at it. And then if you want the percentage, indigenous percentage has to go up, then you need to ensure that the large platforms you should be able to produce in the country. And these are the areas, some of them are what are required today and what are required for tomorrow. Is some of those areas what I have listed, but it will be just their typical, some of those areas I have mentioned here, but a lot more are there which you need to have and you need to develop them in the country. What is required is today, you need to look at the technologies what are required beyond 5 years to 10 years, which will be coming up, and you should be able to work on the technologies today onwards. And that is the only way where you will be able to come out with a technology-based product in timelines contemporary with any advanced nation. See, today, by and large, we have been technology follower, and the role has to change. Either you have to become a technology leader or you have to develop the same technology-based products in timelines with the advanced nations. Then only you will be able to sell your product, you will be able to put into your armed forces, or you will be able to sell all over the world. This is the only way. And in fact, one thing I want to mention here very clearly here is, industry cannot survive only with the market of our own armed forces. It is very difficult. Your numbers will not be that much for the industry to survive. Industry, if it takes a product and starts producing that, at least the industry has to survive with that product for at least 10 plus years. You won't be able to change the lines of the production continuously every 3 years, 2 years, 4 years and all that. So if you want to do that, you need to sell your product all over the world. If you need to sell your product all over the world, then the product has to be the state-of-the-art product, technology-wise, or at least in time domain, you should be in the similar time domains of the technology. And then also cost-wise, you should be lower. These are the two important things. Over and above the maintaining the sustained quality in the industry. This is another important sentence I always use is a sustained quality, meaning product number 1 to product when you are producing 10 lakhs, the 10 lakh number also should have the same type of a quality. These are the three important things what industry need to have. So if you want to have that, you should work on the advanced technologies. You need to engage the academia. You should work with them. So unless you work together with industry and academia, I don't think this you will be able to achieve in the entire gamut of areas what you have today. You need to have a core basic research seriously going on in the academic institutes. The R&D institutes like us should be able to concentrate good amount of their work in the applied research to translational research, not just the development. You should be able to concentrate on the applied research and translational research with the inputs coming from the academia, which is doing the core basic research. And then industry, over and above just being a production agency, has to have a research and development in the niche areas. Today, even in India, there are a number of industries which have come up doing their own research in particular areas and who are supplying all over the world their products. There are many products, whether it's materials or paints or satellite receivers or defense-related electronics and all that. There are many companies which are actually producing within the India with their own research, working with academia and trying to give it. And so that is the type of ecosystem also what you need to have from the industry. So if all the three play their roles as I define, I think we'll be able to come out with products which are state-of-the-art and we'll be able to sell all our products all over the world. That's what I feel, and thank you very much for giving the talk.